طيب. بسم الله الرحمن الرحيم. So I will continue doing this section 4.1. Yeah. This is Newton's method. Okay. It's used to estimate the critical number of the function. And this question, I don't want to estimate the zeros of the function. I want to estimate the critical number of the function. So this is my function. I should not work out Newton's method in this function. Critical number means g prime at x equals 0. Because the function is a polynomial, so never being not differentiable. So I need to check g prime equal to 0. So my function which I will work with is g prime, which is the derivative of this 6x to the power 5 plus 30x. Is it? Yeah. Plus 30. Yeah, 6x to the power 5. Is it? Plus 30x plus 30. Okay, so this is my function. This is what I will work Newton's method. I'll do Newton's method in this function. Okay, let me see what will be the calculation. So I need to find f prime, which is what, 30x plus 30. Okay, now we need to check x2 equal x1 minus f of x1 over f prime at x1. What is x1? x1 is 0 minus. Yeah, this is f of x1. f of x1. What is this? Yeah, 6x to the power 5. 30x to the power 4, but that will not make any effect. He wants x3, not x1, sorry. So this will be 0 minus 0, 0, this is minus 30 over 0, 30. So that will be minus 1. So that equals to minus 1. Now x3 will be x2 minus f of x2 over f prime at x2. And what is x2 is minus 1. So this minus 1 minus. F of minus 1, yeah, f of minus 1, that will be minus 6 minus 30 plus 30. So that will be minus 6 over. Okay. Now, minus 1, I have 30 plus 30. That will be 60. Okay. So I have minus 1 plus 1 over 10. Yeah. This will be 1. This will be 10. Plus. Okay. So I have minus 10 plus 1 over 10, which is minus 9 over 10, which is minus 0.9. So that will be my answer. I need x3. I was thinking of x2. Okay. Same idea. I want to use Newton's method to find the critical number. Critical number means f prime equals 0. So I'm working in this function, not in f, in g, which is f prime on x, which is 6x to the power 5 minus 3x squared plus 2x minus 2. Okay, x1 is given, he wants x3. So it will be x2. x2 will be x1 minus f of x1 over f prime of x1. So that will be 0 minus f of x1. If you put 0 there, 0, 0, 0, that will be 0. Is it? No. Yeah. I am working in this function g, not in f prime, not in f, on g. So I need g prime. G prime will be what? 30x minus 6x plus 2. Okay, now I will work I have x1 equals 0. So x2 will be x1 minus g of x1 over g prime of x1. Since I need the critical number, so I call this g, which is g f prime. I need to find the zeros for f prime, not for f. Okay, so that will be 0 minus g at 0. G at 0 is minus 2. G prime at 0 is 2. That will give me 1. Am I right? Yeah, minus 2 over 2. So x3 will be x1 minus g at x2, I mean, g of x2 over g prime at x2. What is x2? 1. G at x2 at 1, it will be 6 minus 3. This is 0. That will be 3 over g prime at 1. That is 30 minus 6 plus 2. 32 minus 6. That's 26. So I have 26 over 6 minus 3 over 6. That will be 23 over 26, which is this one. Okay. Now let me move to the next topic in this section, which is how to find the absolute maximum, absolute minimum for a continuous function in a closed interval. We have this theorem, the extrema value theorem. If f is continuous on a closed interval, I have two conditions: continuity and on a closed interval. I have the interval closed interval. Then it says what? Then f has an absolute maximum and has an absolute minimum for C and D inside the interval. How to find that extrema, continuous function on a closed interval? How to find it? I need to do this first step. First, I find the critical numbers. Then I evaluate f at each critical number. And then I evaluate f at each endpoint. I need the critical number and the endpoint. Endpoint is given since I have the interval. So I'll find the critical numbers, find f at the critical numbers, find f at each endpoint, which is A and B. The least will be the absolute minimum, and the greatest is the absolute maximum. Let me do it with this problem. So my first step to find the critical number. This function is polynomial, so it's defined, differentiable, nothing to worry about. That's I need to find when f prime equal 0. And what is f prime? 12x cubed minus 12x squared. Is it? Yeah, 12x cubed minus 12x squared. I make it equal to 0. So you have 12x squared, x minus 1 equal to 0. So I have x equals 0 or x equal 1. Is that in the interval? Yes. Is that in the interval? Yes. Now, second step, evaluate f at each critical number. So I need to find f at 0 and f at 1. What is f at 0? Look, this function 0 minus 0, that is 0. F of 1, 3 minus 4, that is minus 1. Now, third step, evaluate f at each endpoint. I have the endpoint minus 1 and 2. So I need to find f of minus 1 and f of 2. What is f of minus 1? That will be 3 plus 4. That will be 7. F of 2. 2 to the power 4 is 16. 16 times 3, 48. That will be 48. Let me do it in a step. Minus. Yeah. 2 to the power 3 is 8 times 2. That is 32. So that give me what? 16. All right. Yeah. 3 times 16 is 48. 4 times 8 is 32. And that will be 16. So the fourth step, the absolute maximum. What is the highest from these four? That will be the highest. The highest. Greatest. He said the greatest. Okay. Yeah. Greatest. So absolute maximum is 16. Where is the least? The least is this. So this is the least. So absolute minimum. Yeah, this is 16 at x equal 2. At x equal to an absolute minimum is what? Minus 1 at x equal 1. Okay. Let me go to, okay. Find the absolute maximum minimum for this function over this interval. This is continuous on a closed interval. Yeah, by the way, this one also, what is it? We should say this is continuous to start with. We say this is continuous on a closed interval. Just to apply the theorem, I need it to be continuous on a closed interval. Okay. So this is the function. My first step, critical numbers. So I'll find this is continuous, differentiable, nothing to worry about, just a polynomial. F prime will be what? 3x squared minus 6x, correct? 3x squared minus 6x, yeah. That will be 3x, x minus 2 equals 0. So I have x equals 0. Is it in this domain? Yes. And x equal 2. Is it in this domain? Yes. So next step, I'll find f of 0. I'll find f of 2. What is f at 0? 0, 0, 1. F of 2, x cubed will be 8 minus 12 minus 3. Now check the endpoints. Check the endpoints now. This is the third step. F of minus half, that will be minus 1 over 8 minus 3 over 4 plus 1. That's it. Yeah, it's minus half. So it will be minus 1 over 8 minus 3 over 4 plus 1. Yeah, what is that? That over 8 is minus 1 minus 6 plus 8. So it's minus 1 over 8. No, not minus 1 over 8. It's, yeah, it's minus 7 plus 1 over 8. 1 over 8. Okay. So I need also to check the other endpoint, which is f at 4. F at 4. That will be what? X to the power 4, which is 64. 4 cubed, 64. Minus 3 times 16 minus 48 plus 1. That give me what? Yeah. This is 16 plus 1, so that is 17. My fourth step, what is the greatest? This is the greatest. And this is the least. So I have absolute maximum, 17 at x equal 4, and absolute minimum, minus 3 at x equal 2. Okay. Yeah, I think the idea is very clear. We can do a function now. What is the function here? F of x equal, I know, I cannot read the function. Yeah. See the function 2x minus 3x to the power 2 over 3. 2x minus 3x to the power 2 over 3. And this is the interval. Here the function is continuous on a closed interval. Okay, so my first step, critical numbers. So I have f prime, that will be 2, minus 2x is minus 1 over 3. 2x over 2, 2 minus 2x to the power minus 1 over 3. Yeah, so that will be 2. I take 2 common factor. I have 1 minus x to the power minus 1 over 3 equals 0. Yeah, this is the function. Where I can rewrite it. Let me simplify it. That will be 2 minus 2 over cubic root of x over cubic root of x. That give me what? 2 cubic root of x minus 2 over cubic root of x. Yeah, that will be my f prime. So I need to find f prime equals 0. So very clear, that means what? 2 cubic root of x minus 2 equal to 0. So x equal 1. So it means cubic root of x equal 1. So x equal 1. Is it in the interval? Yes. So it's a critical number. And also I need to check if double prime does not exist, if x equals 0. Is it in the interval? Yes. Okay. This is my first step. Second step, check f at 1. F at 1 will be what? 2 minus 3. That is minus 1. Check f at 0. That will be 0. Third step, check f at the endpoint. F at minus 1, it will be minus 2 minus 3. That is minus 5. F at 3, it will be 6 minus what? 3 cubic root of 9. Yeah. Cubic root of 8 is 2. Cubic root of 8 is 2. So this will be, yeah, minus point something. Yeah, this is 2 point something, huh? Am I right? Yeah. 3. I need the 3, yes. So this will be 2 point something. 2 point something. I don't know what are these things. So I have 6 point something minus 6. So it's minus point something. Okay. Now, so this is a negative value. What's important is the negative. Why? Because the first step, what's the greatest? The greatest will be this one. This is the greatest. This is minus 1. This is minus 5. Yeah. F of 1, double check 2 minus 3. F of minus 1, minus 2 minus 3. Okay. And this is negative. So this is the greatest. And what is the least? Will be this one. This is the least. So I have absolute max 0 at x equals 0. And absolute min minus 5 at x equal minus 1. Okay, another function. Yeah, I'm doing different functions. Then we'll go to the odd exam. Now I have trig functions. Okay, find the extrema. Okay. Now, first step, first we know that this is continuous on a closed interval. Okay, so my first step, critical number. How to find critical number? Find f prime. It will be minus 2 cosine x minus 2 sine 2x. A plus. Yeah, I'm mixing the things. What's the derivative of 2 sine? That will be 2 cosine. This one, minus 2 plus 2 sine 2x. Yeah, derivative of cosine 2x is minus sine 2x times 2. So this is times minus, that will be 2 sine 2x. Okay, this cannot be, I mean, this is always exist. So we need to worry only about equal to 0. So how to do that? So I have 2 cosine x plus 4 sine x cosine x equal to 0. I can take 2 cosine x common factor. I have what? 1 plus 2 sine x equal to 0. Yeah. So what are the critical cosine x equal to 0? So I have x equal pi over 2 and 3 pi over 2. Yeah, I have full circle. Okay. And sine x equal minus half. When sine x equals minus half. Yeah. Sine x equals minus half. Minus half when this has happened. It's pi over 6, which is 30 angle. But where? In the third and the fourth quadrant. So it means x equal what? X equal it's pi over 6, so it's pi plus pi over 6, that would be 7 pi over 6. And x equal 2 pi minus, that will be 11 pi over 6. Okay. Second step, I need to check f at 0. No, f at pi over 2, sorry. I need these angles. Check them, then check the endpoints. F of pi over 2, f of 3 pi over 2, f of 7 pi over 6, f of 11 pi over 6. I check them all. Yeah. What is f at pi over 2? Pi over 2, I have 2 sine pi over 2, which is, yeah, it will be 2 times 1 minus cosine pi, which is minus 1. That will be 3. If 3 pi over 2, sine 3 pi over 2 is minus 1. And that will be 2 minus 1 minus cosine 3 pi, which is like cosine pi. So it's minus 1. That will be what? Minus 2 plus 1. That will be minus 1. Okay. 7 pi over 6. To sine 7 pi over 6. Yeah. 7 pi over 6 where? In the third quadrant. That will be 2 minus root 3 over 2. Okay. Yeah. No, sine pi over 6 is half. What is this? It will be 2 minus half. Minus cosine 7 pi over 3, which is half in the third quadrant. That will be minus half. That will be minus 1 plus half. And that will be minus half. If 11 pi over 6, it will be 2 sine 11 pi over 6. That will be minus half also. In the fourth quadrant, sine is negative. So that will be minus half. This is minus cosine. Yeah. Cosine 11 pi over 3. 11 pi over 3. That in which quadrants? 11 pi over 3. 7 pi over 3. Sorry. Yeah. Look. What is cosine 2 times 7 pi over 3? That will be cosine 7. Cosine pi over 6. That will be 7 pi over 3. 7 pi over 3, which quadrant? Yeah, 6 pi is 2 pi plus pi over 3. So it's in the first quadrant. So it will be half. So I have minus 3 over 2 here. Sorry. Now, 11 pi over 6, that which one? Which quadrant? Fourth quadrant, that will be negative. Minus cosine 2 11 pi over 6, which is, which is cosine 11 pi over 3. Yeah, where is 11 pi over 3? 12 pi over 3. That is, 4 pi. So this will be the fourth quadrant. So sine will be positive. So it will be half. The same thing. That's the minus 3 over 2. Okay. Then I check the endpoints. F of 0, sine 0 is 0, cosine 0 is 1, so that is minus 1. F of 2 pi, that will be 0. Sine 2 pi is 0. Cosine, this is cosine 4 pi, which is 1. That will be minus 1. So what is the least and the highest? The highest is very clear. This is the greatest. And this is the least. This or this. So I have an absolute maximum 3 at x equal pi over 2. Yeah. And I have absolute minimum minus 3 over 2, but at 2 different places. Okay. Let me do more problems. Find the absolute maximum or minimum over the given interval. Yeah, by the way, I need to be sure first, yeah, it's continuous in a closed interval. Yeah, first one, if it's continuous on a closed interval. First, the second step, critical numbers. I need to find f prime, which is 3x squared minus 3, which is 3x squared minus 1, which is 3x minus 1x plus 1 equal to 0. So I have the critical numbers. No, so I have the zeros are x equal 1 or x equal minus 1. This belongs to the interval. This does not belong to the interval. So I don't care about this. Now I check f at the critical number. So I check f at 1. It will be 1 minus 3 plus 1, which is minus 3. Yeah. Sorry, this is my first step. And this is second. And f, that's it. Third step, the endpoint. F at 0, f at 3. F at 0 equal 1. F at 3 will be what? 27, 28 minus 9, that will be 19. So this is the greatest. This is the least. So, conclusion, absolute max 19 at x equals 3. Absolute min minus 3 at x equal 1. Okay. Now, second question, f of x equal x squared minus 4 over x squared plus 4, which is continuous over this interval. Closed interval. Okay, so I need to find f prime, critical numbers. Yeah, by the way, this is defined everywhere. Actually, cannot be 0. The denominator cannot be 0. So, critical number, do f prime. Yeah, what will be f prime? It needs some calculation. 2x. Yeah, let me do it here. It needs a space. F prime will be 2x times the denominator minus 2x times the numerator over this square. That equal to what? 2x cubed minus 2x cubed is gone. I have 8x plus 8x. That will be 16. That will be 16x over this. So f prime equals 0. I have x equals 0. So my second step, check f at 0. That will be minus 1. My next step, we'll check f at the end point. F at minus 4 will be what? 16 minus 4. That will be 12 over 20. Which is what? 12 over 20 over 4, 3 over 5. F4 will be the same. Since it's x squared, so it will not be affected by being positive or negative. So this is the greatest, and this is the least. So I have an absolute maximum 3 over 5 at x equal minus 4 and at x equal 4. But I have an absolute minimum minus 1 at x equal 0. Yeah. Yeah, let me do this one. Sine, cosine, yeah. Number 3. This is defined everywhere, continuous differentiable, so it's continuous over this interval. Yeah, I have the interval, small interval. Good. 0 to pi over 3. Okay. So my first step, critical numbers. I find f prime. F prime will be what? Cosine x minus sine x. make it equal to 0. So we need sine equal cosine. And that will happen if x equal pi over 4, where I have square root 2 over 2, square root 2 over 2. Okay, so my second step, I check f of pi over 4. That will be square root 2 over 2. This is square root 2 over 2, just square root of 2. My third step, I check f at 0. That will be sine 0, which is 0 plus cosine, that will be 1. F at pi over 3, which is 60. Sine 60 is square root 3 over 2. And this is half. So that will be 1 plus square root 3 over 2. Now, how to decide which one is the bigger, which one is the smaller? Okay. Yeah. This is for sure greater than 1. Okay. And this one also greater than 1, since this is approximately 1.7, 1 point something. So it will be 2 over 2. This is greater than 1. So this is the least. Now, which is bigger? Square root of 2 or 1 plus square root of 3 over 2? Yeah. Yeah, it will be very difficult to decide. Yeah, one idea, maybe it will work. Let me call x1 square root of 2 and x2 1 plus the square root of 3 over 2. Square this, that will be 2. If we square this, that will be what? That will be over 4. I have 1 plus 2 square root of 3 plus 3. Yeah. So I have 4 over 4 plus 2 root 3 over 4. Okay. So it's 1 plus root 3 over 2. This is less than 1. So this is less than 2. So this will be the highest. Yeah. That would be the greatest. Okay. Yeah. I wish that would explain it. So 4 absolute max will be square root of 2 at x equal pi over 4. Absolute min is 1 at x equal 0. Let me add one more page to do number 4. And the remaining just all the exams questions, which is now the same idea. Just will give you function, and then you need to do the calculation. Yeah. Sometimes you need the calculator, by the way, to check. Huh? So f of x, then x over x over this is there for 1 and 3. Is it? Yeah. The function is continuous in this interval, so for sure I have absolute maximum, absolute minimum. My first step, critical number. F prime. Prime will be what? 1 over x times x minus 1 times ln x x squared. That give me 1 minus ln x over x squared. This is, we have a problem at 0, which is not in the interval, so we don't care about that. So we need only to check f prime equals 0. So we have ln x equal 1, so x equal e. Is e in the interval? Yes, e is 2.7 something. So it's in the interval. Second, I'll check f at e. F at e, it will be ln e, which is 1 over e. Third, I check f at 1. That is 0. I check f at 3. That is ln 3 over 3. Yeah. How to check which one is bigger, which one is smaller? Yeah, for sure, 0 will be bigger. This is positive, this is positive, this is positive. So 0 is the least, not the bigger, the least. Okay. Now, I want to check. Yeah, sometimes you cannot do it right away. You need the calculator to do that. So if we do 1 over E, I'm getting something like 0.3678. If I do ln 3 over 3, I'm doing it using the calculator. I don't think you can do it easily. Ln 3 divide by, no, close the bracket, divide by 3. That will give me 0.36620. Wow, they're almost there, but this will be the largest, the greatest. So the absolute maximum will be 1 over E at x equal E, and the absolute minimum will create 0 at x equal 1. Yeah. Let me, that's mainly the idea. Just we'll do more examples. Yeah, let me do 1 or 2 of these problems. All the exams questions, it's the same idea, but I think the calculation will be easier now. Okay, look at this one. He wants the absolute maximum. Have this function, which is continuous on the closed interval, this closed interval, which I'm working with. So it will be f prime. F prime will be 1 minus 1 over x squared. This will be x squared minus 1 over x squared. So f prime equals 0. That give me x equal plus or minus 1. Give me 1. Or x equal minus 1. This does not belong to the interval. So it's out. This is belongs to the interval. 0 is not in the interval, so I will ignore it. This is critical number, my first step. 2, and the critical number over this. Okay. So, 2 will do what? F at 1. That will be 1 plus 1, which is 2. Okay. Then I check F at 0.2. That will be 0.2 plus 1 over 0.2, which is 0.2 plus, this is 2 over 10, 1 over 2 over 10, which is 1 over 5. So that is 5. 0.2 plus 5, which is 5.2. Okay. F at 4. That will be 4 plus 1 over 4. So what is the largest? This will be the greatest. I'm looking for the greatest. So the absolute maximum is 5.2 at x equal 0.2, which is this one. Another problem, let f equal this. So this is continuous on the closed interval. The function I have no problem. So we'll do f prime. First step, critical numbers. F prime, I have product of two functions. So square root 9 minus x squared plus x times, this is minus 2x. Yeah, this is 2 cancelled. Now this is over 1. So you have 9 minus x squared minus x squared over this. Okay. Yeah. Critical numbers are what? I have f prime equals 0. So I have 9 equal to x squared. So I have x squared equal 9 over 2. So x equal plus or minus 3 over square root of 2. Where all of them, they are in the interval. This one, also in the interval. So we have a critical number there, but I will check it when I check the endpoint, which is -3 and 3. So I will do it when I check the endpoint. So number 2, I check if at 3 over square root of 2. That give me what? 3 over square root of 2. Square root 9 minus 9 over 2, which is 3 over square root of 2 times, 9 minus 9, this is 9 over 2, is still 3 over square root of 2. So that give me what? 9 over 2. F of minus square root 3 over 2, that will be minus, it's 3 over square root of 2, sorry. Yeah, 3 over square root of 2. This will be 3 over square root of 2. So that will be minus 3 over square root of 2. Square root 9 minus 9 over 2. That give me what? Minus 3 over square root of 2 times 3 over square root of 2, which is minus 9 over 2. Okay, check the endpoint. F of minus 3, actually they are critical numbers also, but it's okay. F of minus 3, which is 0, f of 3 equals 0. So what's the greatest? This is the greatest. But he doesn't want the absolute maximum. He wants the absolute maximum is at what x value. So I need this. So this will be my answer. Yeah. Let me finish by this one. I think it's not difficult. He wants the sum of these two. So I need to find the absolute maximum, absolute minimum. The function is continuous over this closed interval. So I need f prime, critical numbers. Yeah, it's 3x squared minus 12x plus 9, which is 3x squared minus, 3x squared minus 4x plus 3. So it's 3x minus 3 times x minus 1 equals 0. So I have x equal 1 or x equals 3. This does not belong to the interval, so no need to worry about it. This belongs. So I check if at 3 will be what? 27. 3 squared is 9 minus 54 plus 27 plus 1. 27, 54, that will be 1. 3, I will check the endpoints. If at 2, that will be 8. 6 times 4, that will be 24 plus 18 plus 1. Am I right? Yeah, 4 squared. 2 squared is 4 times 6 is 24. This is 18. 8 plus 18 is what? 26 minus, that will be 2, that will be 3. If at 4, see what will happen at 4. That will be 64. Yeah, 64 minus. Yeah, 4 squared is 16. 16 times 6, that will be 96. Minus 96. 9 times 6, this is 54. Am I right? Yeah, 9 times 6, 9 times 4, what is this? 9 times 4, this is 36, sorry. Plus 1. It's 9 times 4. The number is 4, yeah. It's 36 plus 64. This is 104. That will be 5. So this is the greatest. And this is the least. So this is capital M. This is small m. So capital M plus small m will be 5 plus 1, which is 6. Yeah, I think I will stop the recording and then I will continue in another video. I think the idea is very clear. Just you need to do examples, and that's it. So let me stop the recording. Thank you.